Okay, let's look at exercise 7a. So this topic we're going to be looking at transformations. Now transformations range from a whole range of things from moving things left or right, up or down, to making them skinnier, wider, to flipping them. So we'll look at all the different types as we go through the first few pages, exercises of chapter 7. But the first one, 7a, is just looking at translation, which means we're moving things in the X or Y direction, or left or right, up or down. Now, when you read this introduction here, it can be quite wordy, um, and so it can be quite daunting off the start of the bat. And there's a couple of new notation techniques we're going to introduce in Chapter 7, which have caused people some issues in the past. You can have a read through this in your own time, but the main thing to remember, the new part, and I'm going to pull you over to your summary notes that are up on your shared drive, is that a starting point, we use x, y, just like we did with any Cartesian points, and when we transform that into something new, the new point that correlates to that first point is what we call the image. And we use this notation here with the little x dash, y dash. So the new point is x dash and y dash, and we call those points the image. So the image of x and the image of y. Now, that might seem all good and well. How does that help us when we're trying to apply translations and transformations to different functions? What you've done in the past with your work on quadratics is you've done simple equations like this. Y equals x minus 2 all squared plus 3. And when sketching these graphs, we'd ask you to imagine what y equals x squared would look like. And we know that is a positive parabola, the turning point at the origin. And then look at your new equation. We've got a plus 3 at the end, and so that moves all the points up 3 units. So that turning point would go up to here then. And then we've got a minus 2 inside the brackets, and we just told you to remember, oh yeah, it's inside the brackets with the x, so we do the opposite. So if it's minus 2, we go in the positive 2 direction. So this graph would have a turning point at positive 2, 3, and it'd still be a positive parabola like that. What we're saying here with this new notation is saying that this turning point here is 0, 0. Let's say this is our original graph. If I was to transform y equals x squared into this new one, the point 0, 0 would map to, which means turns into, the point 2, 3. So our 0, 0 is our xy, which is our original point, and the image 2, 3 is our new x and y values. That point has been moved up 3 units and 2 across. So that's what we're trying to introduce with this new terminology. And the reason that we're doing this, and probably the benefit of doing it this way, is that when we actually start looking at functions, we don't have to remember little techniques like, oh, do we swap the x and y's and keep the swap the positive to a negative for the x's and keep the y's the same, that sort of stuff. It sort of makes sense when we start looking at some more practical examples. Really brief notation, if you want to move or translate any function in the x direction, we just need to add a value to that x value. Alright, same thing for the y. So the general rule, the image of x of equals x plus h, that means you're translating h units in the positive direction of the x-axis. For the image of y, if you plus some other number out here, such as k, you're going to have a translation of k units in the positive direction of the y-axis. Seems pretty straightforward. Let's look at another example. Let's clear all this one. So let's look at some of the questions from exercise 7a and see how tricky can they actually get. Alright, we've got original functions here. These are both parabolas at the end, and sketch the graphs of the following, labeling axes and intercepts. We're labeling asymptotes, y-intercepts, and talking about what sort of translations might be happening. So let's look at question 2. In each of the following, find the rule for y equals f of x under the given translation. So the original function for the first one is a hyperbola 1 on x, and we're going translating 2 units in the positive direction of the x-axis and 1 in the negative direction of the y-axis. So let's pull up our little whiteboard here and have a look at question 2a. So my original function is 1 on x, and I want to translate 2 units in positive x direction. Everything about positive x direction would be to the right. And then we're translating 1 unit in the negative y direction, which means down. So without doing any of the notation, you might go, well, I want to go 1 down, so I'm going to chuck a -1 out the end here. And then I want to go 2 units in the positive x direction. So you go, oh, well, I remember that from my quad x chapter. That just means I've got to put in a -2 down the bottom here. Okay, so that would be our new function. However, let's use this same example using the new notation. So if I've got an original graph here, x, y would be any coordinates from this original function, and I want to change them to their new points. I'd say, well, the image for x is equal to the original x, and I want to go 2 units in positive, so I'm just going to be plussing 2. And the image for the y, I take my original y and I want to go 1 down. So when I come to rearranging these, so for the first one, the image of x, if I rearrange this, I can get this top equation here to have the original x as the subject, because this function over here is, let's pretend f of x, let's call it y equals 1 on x. That's our original. That is this value here, this x value, and this y value. So if I want to sub these new images in, I have to make those the subject first. So let's take this top one, and if I want to make x the subject, I'd have to subtract 2 to both sides. And so therefore, x would equal the image minus 2. And my y values, I'd get y dash, and I want to move the 1 away. So I'd have to plus 1 to both sides. So I get y dash plus 1 equals y. Now when it comes to subbing these into our original equation over here, 1 on x, if I sub in x dash minus 2 wherever I say x, I end up getting x dash minus 2 down the bottom here. I've still got that 1 from the original equation. And the y value is over here. I'll have y is now the image of y plus 1. So then when it comes to rearranging that and making the y dash the subject, I end up getting y dash equals 1 on x dash minus 2. And I've got to move that plus 1 from the left hand side. I move it over here and it becomes a negative. And without having to remember any techniques, little tricks and stuff without any explanation, we can see we actually get that hyperbola with a x minus 2 on the bottom, which does represent a translation in the positive x direction and the negative, so it's going right and down. So if we had to sketch it, general hyperbola, we now have asymptotes along the axes, so it's going 2 units to the right. So x equals 2 is one asymptote, and it's going 1 unit down, so y equals 1, and then we just put in our hyperbola shape, find our intercepts, and happy days. Okay, now what I found in the past, I'm going to leave this video here. I don't want to go for a full hour and leave you not enough time to do some work tomorrow, but what I found is that most people will see this question and go straight to that answer, and go, well, why do I have to worry about learning this new technique here of rearranging the image and the original X values? When you put all of the transformations together, so you might have a dilation, a translation, and a reflection in multiple axes, so x's and y's, for example, if you get 4 or 5 of these together and you have to try and find the new equation, it can get quite overwhelming, and it's very easy just to leave off a positive or negative, which throws your whole answer out. So for these easy ones, if you can spot the answer, still try and use this technique here to set up the equation for the image, then make the original x and y as the subject and sub them back into the original equation. And that way, when you get to those harder full-on questions later in chapter 7, hopefully you won't have too many issues. Last thing before I close this off, if you want to check, I know I should be using my CAS calculator, but I'm going to say I did bring it home and I didn't forget to leave it at school. But I do, just showing you quickly on here, if we have a look at the graph, one on x, because I know you did a lot of this with quadratics, so you might look at that and go, I don't believe that's right. Let's have a look. There's our original hyperbola. And if we go y equals 1 on x minus 2, we can see that that shifts, the blue graph is now the image, shifts it over to the right. And then if I chuck a minus 1 out at the end, we can see we did do it correctly. Okay. Good luck with exercise 7A. I'll see you in the Google Chats. If there's any pressing issues and concerns, please don't hesitate to ask for help. Thank you.